Alright, what's up everyone? Welcome back. Today we're diving deep into a battle of titans, a clash of materials that literally builds the world around us. I'm talking about aluminum versus steel. Now I know what you're thinking. Hassan? Metals? Really? I came here for the hot takes, the deep dives, and I get it. But stick with me. This isn't just about boring grey stuff. This is about why your car gets the gas mileage it does, why planes can even get off the ground, and why that skyscraper downtown hasn't just flopped over. Engineers and designers make this choice every single day. It affects everything. This isn't a simple one is better situation. It's complicated. It's nuanced. It's like choosing between your mum's biryani and your dad's biryani. Both amazing, different reasons, family war potential. So, to break it down, side-by-side metrics. Think of it like a video game character selection screen. Aluminum versus steel, stats side by side. Strength, weight, cost, corrosion. First up in our side-by-side metrics showdown. Density. Now, density is just a fancy science word for how much stuff is packed into a certain space. Basically, it tells you how heavy something is for its size. Right here, we see a massive difference between our two contenders. Let's put some numbers on the board. Steel, about 7.85 grams per cubic centimeter. That's pretty dense, the bowling ball of metals. Aluminum, about 2.7 grams per cubic centimeter. For the same volume, aluminum is roughly 1/3 the weight of steel. Imagine a solid cube of steel on a table. Now the same sized cube made of aluminum right next to it. Pick them up. The steel cube would feel like you're lifting a car battery, while the aluminum one would feel more like lifting a big textbook. This weight difference has huge implications. Cars, planes, trains, your bicycle. Every extra kilogram needs more energy to get it moving and more energy to stop it. Make a car part from aluminum instead of steel. The car gets lighter. Lighter car, more efficient. Better gas mileage or more EV range from the same battery. First round winner on weight, it's a knockout. Aluminum, the featherweight champion. Let's talk about the big one, strength. This is where steel flexes its muscles, literally. On a pound-for-pound basis, same size bar, the steel bar is going to be way stronger. We're talking about ultimate tensile strength, the maximum pulling force something can withstand. High-strength steels are absolute monsters in this department. They can have strengths well over 1,000 megapascals. They are tough, they are rigid, they don't give up easily. But raw strength alone is like judging a boxer just by how much they can bench press. It doesn't tell the whole story. What if that super strong boxer is also super slow? That's why engineers use a fairer metric, specific strength. It's a strength to weight ratio. Take strength and divide it by density. It answers, for a given amount of weight, how strong can you make something? When you look at specific strength, the picture changes dramatically. Suddenly, aluminum looks a lot more impressive. It punches above its weight class. Some high-performance aluminum alloys can match, or even beat, many common steels on specific strength. This is why aluminum is the king of aerospace. Every gram counts. So, who wins this round? It's a split decision. If you need the absolute highest strength in the smallest space, and weight doesn't matter, steel is the champion. If weight is a penalty, sports car bodies, jet wings, specific strength rules, and aluminum is a top contender. Alright, let's move on to the next category. How do our metals handle the elements? We're talking about corrosion, or, as you probably know it, rust. You've seen it, that ugly, flaky, reddish-brown stuff that eats away at old cars, forgotten tools, chain-link fences. Plain carbon steel is mostly iron, and iron loves to react with oxygen and water to form iron oxide. It's a chemical reaction trying to turn steel back into the dirt it came from. To fight this, steel needs protection, paint, powder coating, galvanizing, a zinc armor. There is, of course, stainless steel, with chromium, much more resistant, but pricier and harder to work. For big structures, regular steel needs good coatings to survive outdoors. Now, aluminum actually oxidizes incredibly quickly. almost instantly, forming a thin, tough, transparent oxide layer. That layer is like a superhero's force field, sealing the metal from the world. So aluminum has a natural advantage. Window frames, street signs, boat hulls, years outside without thick paint. In harsh marine or chemical environments, aluminum can still struggle, but for everyday exposure, it holds up beautifully. Winner for corrosion resistance, aluminum. Next up, thermal conductivity. It just means how well a material moves heat. Is it a highway for heat or a traffic jam? From cooking your dinner to keeping your laptop from melting. Aluminum is excellent at moving heat, around 200 W per meter Kelvin. That's why heat sinks are almost always aluminum. Steel is way lower, around 50. Heat doesn't travel through it well. Bad for cooling, good when you want to contain heat or reduce thermal bridging. That's why steel shows up in engines and exhausts. If you need to move heat, aluminum. If you need to contain it, steel. So we know their stats, but how easy are they to work with? Let's talk fabrication. Aluminum is softer and more formable, easier to cut, stamp, form into complex shapes. Think about a soda can, intricate and incredibly thin. But welding aluminum is tricky. Heat spreads fast and oxide must be cleaned perfectly. Steel needs bigger presses to form, but welding steel is common, forgiving, fast and cost-effective. Perfect for big builds. Alright, let's talk. The two things everyone cares about: cost and lifespan. On a per kilogram basis, steel is dramatically cheaper than aluminum, often 3 to 4 times. A ton of steel hits the wallet less than a ton of aluminum. Even accounting for weight savings, aluminum parts are usually more expensive. Cost is king, and steel often wears the crown. Now lifespan. Fatigue. Bend something over and over, and it eventually breaks. Steel generally has a fatigue limit. Below a certain stress it can endure indefinitely. Great for vibrating parts, engine components and suspension. Aluminum doesn't truly have a fatigue limit. Tiny damage can accumulate over millions of cycles. So engineers design aluminum parts, like wings, for a safe intended life. For ultra-high cycle applications, steel often lasts longer and costs less up front. The automotive world is the perfect battleground for aluminum versus steel. For decades, cars were big steel boxes, cheap, strong, great for safety cages. Then fuel economy took center stage. Automakers used aluminum body panels to save weight: hood, trunk lid, door panels. The Ford F-150 famously switched to an all-aluminum body, saving hundreds of pounds. But the frame underneath, high-strength steel for toughness and rigidity. The perfect hybrid. Use steel where ultimate strength and crash protection are needed at low cost. Safety cage, chassis, key reinforcements. Use aluminum to save weight and boost efficiency or range. Body panels, engine blocks, suspension components, wheels. The best modern car is a carefully engineered cocktail of both. Aerospace. Aluminum's kingdom. When you're fighting gravity, weight is everything. Aluminum's fantastic specific strength and track record make it the primary choice for fuselage, wings, internal ribs. Steel still appears where ultra-high strength is critical. Landing gear, high-strength mounts. Even as carbon fiber grows, aluminum remains a cornerstone. Construction. Lean heavily on steel for the load-bearing skeleton. Skyscraper, stadium, bridge. You need predictability, massive strength, and cost-effectiveness. Steel fabrication, welding and bolting, makes giant projects feasible and fast. Aluminum takes the skin, curtain walls, window frames, decorative panels, light and corrosion resistant. It's not a rivalry, it's a collaboration. Use the right tool for the right job. So, after all that, what's the final verdict in the ultimate face-off between aluminum and steel? The truth is, there's no single winner. The best choice depends entirely on what you're trying to do. It all comes back to our side-by-side metrics. Look at the stats and decide which ones matter most for your project. It's about making smart trade-offs. The real winner is the engineer who knows when to use which material. Automotive, steel for strength and crash protection at low cost. Aluminum for weight savings. Panels, blocks, suspension, wheels. Aerospace. Favor aluminum for fuselage and wings. Use steel for landing gear and ultra-high strength parts. Construction. Steel is the bones, aluminum is the skin. Both are essential. There's no one-size-fits-all answer, only smart choices. After this, you'll see the world as deliberate engineering choices.